Okay, is climate change really real? Part two. Suppose, no, it's not. All right, suppose 32 weather stations were randomly selected across the globe. For each station, the peak annual temperature degrees Celsius between 1900 and 1940 was found. Then the peak annual temperature between 1960 and 2000 was found. The differences were calculated for each station, later temperature minus the earlier temperature. Mean of the differences was X bar difference equals 0.35, and the standard deviation is 0.296. Okay, it's the same thing as last time. One thing I want to note, whenever you're doing like difference, you need to state which one you subtracted first. So like if you did later minus earlier, you need to write that down, because if you don't, the reader doesn't know. Again, assume the reader is dumb. Okay, is there convincing statistical evidence that the peak global temperatures increased on average during the 1900s? So what type of test are we doing? Okay, plot twist. One sample t-test for mu difference. We are matched pairs t-test. Do you remember? It's the same location, but we're just giving it both before the 1940s and after the 1940s or 1960s. Sorry. Yeah. So one sample. Okay. The two sample is two separate things. Matched pairs is it's in one location and you're doing both. Remember that whole concept of the two coffees? Yeah. One person, two coffees? Same concept here. So that's the matched pairs t test. One sample t test for M difference. This is also known as matched pairs. Okay, the significance level is 0.05, even if they didn't tell you. Okay. The statistic is X bar difference is equal to 0.35. The parameter is mu difference, which is the true mean difference of peak temperatures. Remember, state like the subtraction. Love it. True mean difference of peak temperature late minus early. Well,
true mean difference of peak temperatures between a level above and a level above.
Yes. Yes. You just need to say like which one you subtracted first. Okay, fine. You good?
Yeah.
Awesome. You like that. All right, hypothesis. The null is going to be that the mu difference is equal to 0. The alternative is that the mu difference is greater than 0, right? Because we're trying to figure out if it has increased. I feel like the alternative is the hardest part. Like defining what it's not null. Okay, make sure that you pay attention to your question. Okay, evidence for the alternative. Well, we have that X bar difference is equal to 0.35, which is greater than 0. Okay, thanks, Paul. Go ahead and check your conditions. 0.35 is greater than 0. Okay. 10 minutes of sleep. I mean, you know, I took penmanship when I was in first grade, and that was my only B plus like ever. Now you see why. But they also taught us cursive before they taught us print. Like I didn't learn print until third grade. So I can write really pretty cursive. You can't read it. But I always hated the T's, so like this is stupid. This is dumb. Exactly. You wanna see my signature? It's really trash.
I don't know what side of that, like, wow,
Because you can't repeat it. There, I am Beyonce, and so I just go by my first name.
I so T.
Dayolor. Because, all right, think about my last name. What does that signature actually look like?
You can, oh.
It's MMONS. Like,
That looks like
so dumb.
I could see the.
It's okay. Because the fiance is taking me from the beginning of the alphabet to the end of the alphabet. So now I'm going to be. I know. No, I gotta practice my like signature. I'm gonna make it pretty. It's fine. Warren. Bro, I literally went from EW. I'm so upset. But you know what? I can go by like Coach War. You know?
Wait, let's look at that.
Right? Kind of? Yeah? No? Okay, so for like 6 years of me teaching, I was Coach Emmett. And I moved to Peachtree Ridge. I went by my first name because I was like, eventually I'm gonna get married and I want to have to change my like school name for like the kids because like that's just confusing. Like call me by my new married name. Like no, that's weird. So here we are. Here we are. Coach War.
We just
I think that's a great idea. No. Sal, you're failing my class. Oh, I'm so sorry. I know I need to put all this stuff in. I graded chapter 10 and then I sat down last night at like 11 p.m. after middle school practice and I was like, okay. Like, it was stupid. So today is the day that I'm going to get more things put in. I don't know about everything, but. All right, random sample of 32 stations. Okay, 10%. We've got 32, which is less than or equal to 10% of all stations. What? Yes, sorry. It's the same location. If you are getting different samples, you would be like, hey, let me split the locations up and then get 2 samples. Does that make sense? Okay. I know that's a little tricky. All right, for normal or large counts, we got 32, which beats the 30. So CLT is cool. Okay, what about the random sample? Do we show causation or do we generalize to the population? Generalizing to the population. Remember, random assignment, we show causation. Do I need to say it again, Sal? Okay. Sampling without replacement is okay, right? And what does CLT do for us? Approximately normal. Okay, there's gonna be a multiple choice question about that. It's gonna happen. On the quiz, I think it's 8. Say what? No, the last test you took had 9 questions, and they were multiple choice, and then you had your FRQ. I just forget. I'll look back at it. I also am guessing because I don't remember. Like I got to go back and look at it. So, all right, test statistic is equal to the statistic minus the parameter over the standard error. I know. Standard error. Specific formula is going to be X bar difference minus the mu difference divided by the standard difference divided by the square root of n difference. Fabulous. Also, like mu diff, n diff. Sounds weird. Hey, are y'all taking notes or are y'all talking over there? I got really scared. I was like, there's a bandit in my room.
Not scary.
I'm like, thank you. I hope this isn't 87, not 37.
Or the 87.
Oh, thank God. Okay. All right, we're good. My One Piece boy. Who is this?
We're talking about.
Oh, that makes sense. That checks out. Okay. Y'all are good. Thanks, friend. Right. You ready? Okay. So when we plug in all the junk and we get all this information from the top, we get 0.296 divided by the square root of 32. And that means that our T is 6.69. So if P is 6.69, what is our P value? How do we find that? You can use calculator or the table. I need you to make sure that you know how to do that for this unit. So if you want to do it in the calculator, do it now. If you want to do it on the table, do that now. Let's go. Practice. What are y'all talking about? What? Really quick. Okay, let's talk through how to do this in your calculator. So how do you find this in your calculator? You go to menu. Everybody do it with me. Do it with me. All right, ready? So you go to menu. You go to stats. Then you go to what? Stat test. P-test. And then you're going to input statistics. You're going to put stats in. So what's your mu? 0.35? No. Oh, sorry. Your mu is 0. Your x bar is 0.35. Your standard deviation is 0.296. Your n is 32. And do we want greater than or less than or equal to? Or not equal to? So we want greater than. Yes. So we're going to say approximately 0 because like 0.08 to the negative 8th power is 0. Good? Okay. All right, we're going to conclude. So assuming that the null hypothesis is true, assuming the null is true, that the mu difference is 0, there is a 0 probability of getting x bar of 0.35 or greater purely by chance. And because 0 is less than 0.05, we reject the null and do have convincing evidence that peak temperatures increased in the 1900s. Questions? What?
Less than 0.05, maybe less than or no?
No, it's not going to have it like that. It'll be like that. Yep. Okay, pull it to the back. Okay. So we did the 4 C's. It's just like what we did last time. We do want to talk about 1 sample versus 2 sample. Okay, and we kind of had this discussion earlier. But t-test for mu difference versus a t-test for M1 minus M2. Okay, so t-test for mu difference and t-test for mu1 minus mu2. Mewtwo. Yes, like the Pokemon. All right, one sample. This is paired. That's what this one is. Okay, you're going to find the mean difference. You're going to subtract, then average. So you find the average of the differences. Does that make sense? Okay. On this one, it's two samples or groups. Okay. And you will find the difference of mean, average, then subtract. So like that one would be, we divided the locations up into two separate groups. We find the average temperature in that group, and then we subtract the difference between those at the end. Does that make sense? There is a difference between the two. Cool. All right, go ahead and try your check your understanding. You're telling me what type of test are we running? Okay, so this is pretty good practice. Go ahead. Good. All right, let's talk through these. A random sample of 30 adults. Shh, I'm reading. Okay, a random sample of 30 adults were selected. Each adult reported the number of pieces of junk mail they received in their mailbox at the home that day, as well as the number of junk emails they received in their inbox that day. A researcher would like to know if the adults receiving significantly more junk email than junk mail in their mailbox. Is this paired T procedure, two sample T procedure? Why? It's one sample, and there are two measures, right? I'm saying, hey, everybody in this classroom, how much mail did you get in your inbox as well as your physical mailbox? Does that make sense? Question? Fantastic. A random sample of 100 people who live on the West Coast and 100 people who live on the East Coast are selected. Each person reports how many spam calls they received in 1 week time period. We'd like to know if the people who live in the West Coast receive significantly more spam calls than those who live on the East Coast. Yes, it is two sample because we have two independent samples, right? Why is it a T procedure and not a Z procedure? Look at the main difference. Okay, what? Difference of mean. Okay.
You see how many spam calls they receive, not like how many like calls they receive, it's just how many is there.
So when we talk about T versus Z, we're talking about population versus sample. Does that make sense? Okay. All right, last one. A researcher takes a simple random sample of 15 cell phones from different manufacturers and different service providers. The researcher measures the signal strength from two different remote areas, one in the state of Pennsylvania and one in the state of Virginia. The researchers would like to know if the signal strength is significantly weaker in the remote area in the state of Virginia. This is matched pairs. Why? Okay. Okay, and they're paired for each cell phone. I feel like cell phone. Remember our conversation about how like AP Stat is really just like gossip?
Yeah.
Okay, I feel like majority of these are just like first world problems.
Yeah.
Like, look at all these examples. Like, oh my God, I got junk mail and email that was junk. Like, oh darn, you know? Sorry. Huh? Say it again. Sorry.
You have to write two measures.
Andy, yes, that's fair sample would be 3 and 1. 2 is 2 sample. Okay, go.
Do I have to write two measures in the first question?
Oh, wow.
Yeah. So you say junk mail and email. Mm-hmm. I kept pointing at both of like he was like, so he thought I was talking to him. I was like, this is getting worse. All right.